Good morning, everybody. Thank you for joining. Especially thank you for all of you who came from the West Coast and realize it's basically 5 o'clock in the morning or something like that right now. Yeah, way too early, way too early. The talk's called Architecting in AWS. It was originally called Failing in AWS. I figured I'd do something slightly more positive than that. Feel free, any questions that come up, ask them. I'll do my best to just take them as we go. There should be time for it. There'll also be a QA at the end of the session. I'll be right there when we're done. You can buy me drinks later, whatever works for you. We'll publish the slides when we're done. And I'm pretty sure since I'm being recorded, there'll be a nice video of the event as well. So if you're taking notes, checking your mail, it'll all be there. As we go through the slides, you'll see some sort of off-colorish links on the right-hand side of the slides. Anytime I'll be throwing out numbers or whatnot, there's all the research material right behind it. So when you're looking at them on SlideShare, that's where it'll be. Come on in. That was a good moment when people stand in front of your session, looking at the schedule, looking at you. It's like, am I coming in? I don't know yet. Maybe I will. Maybe it's. So hey, a little bit about me since we didn't do introductions today. My name is Jos, and I used to work at a company called the RIPE NCC, which is where you go to get IP space if you're in the Middle East or Russia or in Europe. If you're American-based, you'll go to ARIN. And after that, I went to a company called Canonical. Anybody here run Ubuntu on their servers? A few of you? A few of you still stuck on RHEL 4? Yeah. I was running a piece of enterprise software yesterday. I was at least trying to, and they told me the only supported platform was RHEL 4, which I believe has been end of life more than a year ago. Anyway, so I was the engineering manager for Ubuntu Server 10.04 and 10.10, and it was the first series release that was done for EC2. It's, in my opinion, still the best operating system you can run inside of EC2. We spent a lot of time specifically on the kernel and on the integration with these bits. And it's definitely the most popular one still. If you're running Java on Ubuntu, I do apologize. So after that, I figured it's really cool to build an operating system like that and work on the infrastructure, but it would be really neat to actually get to run it inside of EC2. And so I joined a company as their VP of operations, and the company I work for is called Crux. And the way I explain it is the way I explain it to my mom. It's kind of like Google Analytics for audience rather than traffic, or that thing that Netflix does to figure out what you want to watch, and that thing that Amazon does to figure out what you want to buy. We do that for everybody else. And so for any type of content you want to consume, we help you figure out what that is. And here's a list of our customers to kind of give you an idea of where that might be used. It's a pretty common issue if you are a publisher of any style. You probably want to have recommendations for articles that people continue reading so they stay on your site. You might want to inform your ad choices so the ads are more relevant to the users they have. They click through, you make some money. For the folks standing in the back, there's plenty of seats up in the front if you want to come up. We also do a lot of work on the data privacy side of things. We believe that any data that you share with your with the publisher you're on, like say the New York Times or Wall Street Journal, it's a contract between you and them, and it should stay that way. It shouldn't be hijacked by third parties. And it turned out that is a very specifically important thing in Europe, where the data privacy laws are much more rigid and much more stringent than they are in the US. So we saw a lot of traction there, specifically on the dealing with consumer data privacy. So since we're on all these big publishers, and a bunch of these are top 50 websites around the world, we get lots of traffic. We basically get at least one call per click on their web pages from all over the world. And we're on the critical path for all of them. Like our content, the thing that we deliver to them, informs the content that they're going to show their users, whether that's an ad, whether it's the next article, whether it's a customization of any type. So that means we're on the critical path. It also means that outages become very, very bad. A lot of these sites are consumer sites in the end, but for us, they are enterprises. We have stringent SLAs, and we have things that we need to live up to. So to give you a little bit of color to the numbers I'm talking about when I say lots of traffic, I'll prefix it by saying it's an apples and orange comparison, but Twitter gets about 6,000 to 7,000 tweets a second. That was just confirmed again next door in the Twitter talk, which is really good if you were there. They do a bit more work on their incoming tweets than we do with our calls, but it's new data points every second. Their record during the last World Cup was around 15,000 requests a second, and that's our daily peak. So that's the amount of new data that we get in every second continuously. And we do about 85,000 requests a second over our infrastructure. In terms of monthly uniques, we reach a few more people than Wikipedia. I think the latest number is about 760 million a month. And we process the analytics for those users in real time. As they come in, we process. We have a key store for our user profiles, which is about 900 million users, and we process about 11 terabytes of data every day. And we chose to do that in the cloud. Thank you for that vote of confidence. I would argue it's a really good place to be for startups. It's a really good place for startups growing fast. The trade-offs are obvious. The CapEx is really, really low. You can't go to a venture company and say, can you please give me $50 million to buy all the hardware to prove my idea? So by default, you'll be urged to go somewhere where a data provider helps you with this. The downside is the OpEx can be incredibly, incredibly high. It's great for the fast and flexible infrastructure deployment. It does give you a very controllable price point with no upfront investment. These are all great things, and there are great components, great services built for you to build off of. Obviously, it's not all good news. It has happened more than once. The failure modes are completely different. I think that's the biggest ones. If you know your failure centers in a data center compared to your failure centers in the cloud, they're worlds apart. For one, you don't control the network anymore. There is no such thing as a dedicated 10 gig Ethernet cable between a master and a slave. Those days are over. You can't add a power supply for something that's critical. You definitely can't get diesel generators or UPSs or, God bless them, memory-backed RAM. Things will fail outside of your control, and you're going to have to deal with it. And one of the challenges is that the cost can go up really, really quickly if you try to deal with them the same way as you did in a data center. So why am I standing here and talking to you about this? This is a chart without numbers because I was required to remove the numbers, but the sizing and the shape matters. If you want to build a system that grows and you can't control your costs, it's not going to work. And it has to be resilient. So anyway, this talk is about our experiences. It's about the trade-offs that we chose. There are choices that have led us to grow 9 to 10x while keeping roughly the same cost profile. And this is all of our costs. This is our AWS cost, it's the CDN cost, it's the DNS cost, it's all of it. The revenue number you see there tracks our requests per second and our unique users, and that is how we get paid. So for everything that we do, we get paid. So they track one-to-one. I think the thing that I'm most proud of is that because of that fairly flat line at the bottom, we've avoided at least one round of funding, which is huge if you're a startup. I mean, that's 30% more stock in my pocket right there. I'll cover a bunch of these resilience techniques we use. I'll cover a bunch of cost-saving techniques, and we'll go into some anti-patterns at the end. So as I mentioned, we deployed in Amazon. I'll focus on that. I think it's the gorilla in the room. It's definitely the most fully featured one right now. We targeted, added Ubuntu. Crux built on top of it, so I definitely have the most experience there. So it'll be a little bit Amazon-centric. First, a little bit of a history lesson. Who was in AWS back in 2011, early 2011? Were you around that day, April 21st, 2011? Yes. Yeah. Was that a good day for you? Was that? No, it wasn't. It was the first big EC2 outage, and it was a huge one. Lots of companies were affected, and it was then that the stability and the dependency on EC2 was questioned. Can you actually deploy a real company on the cloud? Did you make a huge mistake? So what happened? A network change led to a cascading failure. It took down their EBS solution, which is their SAN solution, RDS, their hosted database solution, and basically any other network service with it. The load balancer stayed up, but that was about it. As a result, Netflix and all the other guys on the cloud, they published their postmortems. and explain how they will compensate and how they will deal with this going forward. And we've all gotten better at it over time, but as the other 3 dates show there, it happens again and again and again. So why does it? A couple months ago, there was a study released from somebody who took all of the postmortems from Amazon, all their public declaration, all the stuff around the problems they had, and analyzed them to their root cause categories. And it turns out most of the problems are not related to the fact that you're running on somebody else's hardware. They're not that they're buying commodity stuff. It's not that they chose the wrong architecture. There were human and process errors. People make mistakes. We make mistakes, and they make mistakes. So one of the assumptions you have to go with is that Amazon, because mistakes will be made, will break your stack. It's going to happen. So let's go forward to June 29th, 2012. A big storm hits the East Coast. And now the irony is not lost on me that it's a storm that takes out the cloud, which I thought was kind of poetic. But it basically cut power to a good chunk of US East, Amazon's biggest region. All the ELBs suffer a latency spike. Their API is down. You cannot launch new machines. You cannot change your configuration. US East is mostly unusable. An entire region outage like that is very, very rare, but it does happen. And if you can't redirect traffic at that point, you will be down, which is what happened to all these guys. AWS outage becomes your outage. All of these guys have had extended outages when AWS had one of these problems. I actually think it's because they use red in their logo, and that's just a really, really bad idea. So just go with a blue logo like we have, and you're going to be fine. But we, knock on wood, we weathered all of these outages so far. We didn't lose any significant amount of data. We had degraded API calls, but all operational within our tolerances. So let's talk about resilience. The things you took for granted in the data center may not apply. The strengths and weaknesses of your platform have completely changed. You will have network partitioning. We see it multiple times a day. You will have very unreliable disk I/O, orders of magnitude in some cases. Your IP addresses will change. And your instances will randomly fail. And your architecture is going to have to change as a result of that. But first things first. When we talk about availability, what does that mean? I think a lot of us traditionally think of it in terms of uptimes of servers or something like that. But in my opinion, availability is the user experience, not your machines. Slow servers will degrade your user experience. They might be up, but your users wouldn't agree that your service is working. And conversely, your service might be down, but if you degrade well, your users may not even know. In the Twitter talk just next door, they said after they did a data center migration, they tweeted, "We just switched data centers. Hope you didn't notice." That's fantastic. They changed over everything, and nobody noticed. So let's take a look at a very, very basic API call. This is about as vanilla as it gets. You make a request for maybe some profile data. You hit an API, some business logic, looks it up in a database, returns some JSON. Couldn't be simpler. You have 3 potential points of failure here. Your API server might break, your database might break, or your network might break. But does it really need to be fatal? Think about your app. If your database is down, could a cached copy do the trick? If your API is down, does your front end know how to cope? Here's some pretty straightforward some straightforward fallback patterns. You should consider the cost of resilience to be either accuracy or latency. Let's go through a flow. Ideal scenario, everything is up. We go through the top flow. Number 1, you just hit the database as before, the return value comes back. What if the database is slow? Fall back to pattern number 2. Rely on an object cache of some sort, maybe Redis or Memcache. It might be slightly stale, but you're still serving. Your entire database tier just went away. Amazon broke RDS. Nobody needs to notice. What happens if your API slows down? Fall back to number 3, rely on an HTTP cache, maybe use Varnish or something like that to serve stale data. What if that one doesn't work? You can have a CDN in front of it that knows how to serve stale data. And what if that doesn't fail? What if that doesn't work? You can still rely on HTML5 local storage to put a copy of your cache data there. If you control the client, if you control the JavaScript that makes the call, if you have a native client, whatever it is, you can use that. And this is just an example. Step 5 doesn't have to be use HTML5 local storage. It could also be try CDN number 2. The bottom line is design your system to pay for failure with either accuracy or latency. Don't just fail. Back to my point about user experience. This is me posting a tweet. How did that work? Was that a post to Twitter, and then they refreshed the page for me? Was it a post and an AJAX partial refresh? Did the client just update the UI and do an async post in the background? Was Twitter even up when I posted this, or did they just show it to me and kept retrying in the background? And it says 19 seconds ago. Did my followers get the tweet 19 seconds ago? It doesn't actually matter. It worked for me. And within a few minutes, my friends told me my tweet was funny. So it was up. And similarly, when I hit refresh and the API is slow to respond, you could repaint this entire canvas using the last, say, 100 tweets from local storage, and then update with new tweets as soon as the API comes back. Let's talk about some tooling about how we can actually achieve this. Step 1 in Amazon is consider using smaller machines and more of them rather than larger machines and fewer of them. Here's why. The impact of a machine loss impacts what the other machines need to be able to compensate for. The larger the machine is that fails, the more the other guys have to do when it fails. Not if it fails, when it fails. And this is one way to keep both your costs and your resiliency in check. With larger machines, you need to over-provision more to avoid that service failure. So for example, take 2 C1X larges, take 1 in every availability zone that you want to use, or 4 C1 mediums, 4 in the 2 availability zones you're going to use. They are, in terms of capacity, identical. A C1X large is literally 4 times the size in disks, in CPU, and in RAM of these medium machines. But what if a machine fails? In the case of a C1X large, the one remaining machine needs to double its traffic, so that it can be at most at 50% utilization. One of the C1 mediums fails, there's 3 to compensate for that in that zone. So the way we allocate is either for a full zone failure or a single node failure in every availability zone we're in. It's proven a very cost-effective way for us to continue to be up for our clients, but also keep our costs very much in control. So my advice would be to pick a node size that you like, or maybe 2, and use as many of those as you can. It'll also help with reservations, which is what we'll talk about later. We like C1 mediums a lot. They're tiny, but we can have many of them. Doing this early also proves your horizontal scaling model much, much earlier. It's very tempting to go for bigger machines first and then scale out. The next one on databases. Anybody not familiar with the CAP theorem? Smart crowd, awesome. So every data store adheres to it. Consistency, availability, partition tolerance. It's kind of like cheap, fast, good, pick any 2, except you get to pick 1. Partitioning is a very frequent fact of life in AWS. Like I mentioned, we see it many times a day. Often just for a couple of seconds, but sometimes for hours. It happens. So your choice is to sacrifice availability or consistency. Now, when you think of consistent data stores, think of ones like MongoDB, MySQL, or HBase. And when you think about available stores, React, Cassandra, Dynamo, Couch. My advice would be that unless you run a stock trading system, or maybe some sort of medical monitoring system that administers morphine at a very precise rate, and you better not mess that up, pick availability and eventual consistency. It'll make your scaling so much easier, and it'll make your resilience so much easier. I'm going to give a quick shout out to Amazon S3. And if you're using Amazon and not using S3, I'm very confused right now. It's their best feature, if you ask me. It has a ridiculous a ridiculous amount of uptime and availability. It will be available when nothing else is. It's HTTP-based, so most languages even have a binding for it. It is the most durable, most available data store in your arsenal. If you care about your logs, push them there with log rotate. We do it every 10 minutes, for example. Compress them and save 80 to 90% off of your bills, and use LZOP plus indexes so your EMR can chunk them and process them more efficiently. It's fantastic. If you don't care that much about your files and you can lose one every now and then, use reduce redundancy and cut your costs in half even still. The reliability that you get from S3 is paid for by higher latency. So a fuse file system would never work, definitely not for writing. And understand that a call can often take upwards to a second to actually complete, but it will complete. And on a retry or a second retry, you basically have a 100% success rate of that call. As I mentioned before, caching are a very important part of your resiliency toolkit. Cache your requests. In almost all cases, cache data is better than no data. You can use Varnish to cache common responses. You can set a very reasonable TTL and cache headers. You can set a grace in Varnish of 2 to 3 times the TTL in case of a backend failure. Grace is, I know my TTL expired, but what if the backend isn't up? Continue serving the thing even though the TTL has expired for some time longer. And of course, use Redis or Memcache as blob store for your SQL results or your JavaScript snippets. If you are lucky enough to control the client or have JavaScript on the page of the client, use HTML5 local storage. Really, all your data does not just need to live on servers. It does not need a round trip. Older data can provide a very, very reasonable fallback when your servers aren't reachable. And client-side storage can do this for you. It's 5 megs per app, and it exists on mobile devices, where latency is even more important. And the best part of it, it's totally free. You're not even paying for it. In our case, having 900 million user profiles times 5 megs each, that's a lot of available storage that we would have to provision very close to end users. And nothing gets closer to the end user than being on the physical phone. All right. ELBs, use them. They should be part of your strategy. They are incredibly economical. You can put 30 terabytes of data through them for less than $400 a month. They will autoscale and rebalance as they need to. And it definitely beats running any HA proxy instance yourself. Although I've heard people do this, and I really want to hear about the benefits that you're deriving from them. So quick show of hands, who's running their own load balancer in EC2? You are?
Well, no, but I mean, one of the concerns with the ELB is they don't scale very quickly.
One of the concerns of the ELBs is they don't scale very quickly. My next note here says, note, ELBs take some time to warm up. If your traffic rises or drops sharply, reach out to AWS support and get them to do it for you. Most people don't have these types of problems. Most people don't have huge websites. Most people aren't affected as much when Boston is bombed or Kate has a baby. But we are, and our traffic rises very, very sharply. We see enough people across the internet now that we know how quickly news travels and basically what the maximum extent of a news event is, which in our case is about 60% traffic increase. That's just what happens. And so we know this, and we can plan for it accordingly. The folks at AWS support are incredibly helpful, but you do have to tell them or it doesn't happen. So here's the downsides. There aren't any private ELBs. They don't exist. You need to be in VPC to do that. They don't support WebSockets over HTTP. It's very, very confusing. So you're going to have to do TCP yourself and then deal with SSL on the far end yourself. And they only work per region. So if you are in a certain region and you have problems, you still need to get out. How do you do that? Is there anybody here who runs a website they're quite proud of and is only in a single Amazon region? I will accept a small show of hands, not a high one, and I'll promise to keep your secret. Anyone? Good jobs. For the obvious reason, it gives your users much better latency. But it also lets you fail over, and that's probably the most important part. So on a TTL you specify, we personally use 15 minutes. That is our comfort level with total failure of a zone, 15 minutes of no new data coming in. We will fail over to an entirely different region. This is actually our failover model. So we have data centers in those 5 places, and if one of them goes away, you can see how the traffic is being rerouted closer by. When your DNS failover is happening, that's also a great time to be reading from your local storage and make sure that nobody knows what's going on. But make sure that you configure your DNS provider to do this monitoring for you on your individual data centers and does the failover when you need to. If you're a US-focused company, run it in US East 1 and US West 2 and do the failover. We also use global DNS rules for things like new versions of code. We will upgrade a certain data center. Well, we'll siphon a bunch of data traffic away from it, then upgrade it, and then start slowly siphoning it back in. Or even when we have to do entire data center upgrades, we fail them over and we move them back in like that. And on that note, I like to give a shout out here to Dyne. Who uses Dyne for their DNS? That is the smart side of the room right there. So AWS offers Route 53 for DNS. It's fully featured. It's really neat, but we use Dyne, and we are very, very happy with them. They know what they're doing. They're priced really, really well. They offer fantastic support. I think there's a few folks here from Dyne. They'll probably happily sell you things. And quite frankly, without them, that last AWS outage, when they actually took out the East Coast data center, we would have lost data. And then probably what is my favorite picture of the entire presentations. Humans do dumb things. So as much as we've talked about the technology behind the resilience, there's also the human component of the resilience and the mistakes that people make. And Amazon gives you things called IAM roles for free. It's called the Identity Access Management roles. And the whole point is that you set up the access and only give people access to the thing that they need. It's very, very obvious, right? But it also lets you isolate the process and user mistakes to the smallest possible zone. You know, when somebody's cleaning up their S3 buckets automatically, maybe you don't want to give them access to your backup buckets. So when they do rm-rf over the S3 bucket, all your backups are gone. Point is, these mistakes will happen. We've all been in places where code's been deployed and somebody just didn't think about all the things, and it's our jobs here to make sure that they don't. All right, enough about resilience. Let's go on to cost. Anybody have any questions in the meantime, by the way? Just feel free to shout them out. Sir?
From a sort of a balancing standpoint, have you ever considered running, like, has it ever come up to run in multiple cloud providers like Google Compute and Amazon?
Have I ever considered running in multiple cloud providers? Yes. We do an exercise every couple of months. The way we look at it is if our runway is more than 9 months, it's fine. We'll revisit. And what is the benefits we get? And I think if you see us going into this cost perspective next, there are a bunch of things that we use very economically that others don't really offer. And there'd be quite a large overhead for us to make it provider agnostic. In our case, I don't want to say it goes for you, but we've come to this conclusion that we would be coding towards the lowest common denominator, and we don't want to do that. So that's our reason for not doing that. Good question, though. So cost at scale. Let's take a look at what they are. Amazon provides a great set of tools for some stuff. There's some patterns you can follow, and there's a bunch of third-party software. I'm going to try to just go through all of that. The first one is MapReduce and Spot instances. MapReduce, EMR specifically, beats Hadoop if you have spiky jobs that don't fill a cluster continuously. If you run your own cluster, you want to sort of distribute the load and make sure you get full utilization. If you have developers who want to use MapReduce, they go, I want it then, and I want this many, and I want it now, which is kind of crappy if you're an operations person, but this is where MapReduce comes in. But most of these jobs run for about an hour, 2, 3, 4 on the outside. And so it turns out that if you use Spot instances to run your MapReduce, you can get your cost down to a quarter, maybe 10% even of what they would run otherwise. The bid price for Spot instances is the maximum price you're willing to pay, but you pay the current rate, which is less than your bid by definition. And so it works great for temporary loads like encoding, compressing, maybe queue backlogs, or as we tend to do, Jenkins and AMI builds. It's great stuff for that. The cost reduction is up to 83%, and that beats the 65% you can get on a 3-year reserved always-on instance. So this is cheaper than reserving your full capacity up front with none of the risk. But note that the price per region and per zone can vary wildly. So you will probably want to do a little scripting and figure out what the cheap zone is at the time. And if you're really, really paranoid, bid 101% of the on-demand price, and your instances would never get terminated. So on those few cases where somebody's automated bidding robot goes crazy and actually bumps it up to the on-demand price, your job's still running. You're no worse off than having used on-demand to begin with. It's a pricing trick, no more. Who here is using Redshift? Cool, handful of folks. The way we like to think about it is that RDS, their hosted database solution, is for OLTP, and Redshift is for analytics and reports. At $1,000 a year a terabyte, it's incredibly, incredibly economical. We haven't figured out anything that we could throw up against that at the scale that we're using it at. It speaks Postgres, so it basically works with all the UIs that are out there. And one of the things that we found that works tremendously well is we have our incoming data, we have a bunch of MapReduce jobs. One of them writes summary and reporting data into Redshift, and we have a license for Tableau for our business folks, and they can just query to their heart's content. No more writing MapReduce jobs for us, no more needing to know your queries up front. It's like instant BI for your marketing team. It's awesome. Glacier, anybody still use physical tapes for things? Of course you do. One lone hand in the back. So Amazon Glacier, I read it as like tapes for the cloud era. It's long-time data storage. It's great if you have compliance reasons. I know a bunch of us do. It's also great if you want to archive data that you really want to keep but probably don't access. It's a penny a gigabyte a year. It's fantastic pricing. The thing is, the reads are very, very expensive though. If you retrieve less than 5% of it, you're not paying them any, but after that, you're paying them 33 cents a gigabyte, so it adds up really, really fast. The cool thing though is you can expire objects older than some sort of time from S3 and move them to Glacier, which is what we do with our log files. We process all this data over the last 90 days, so any type of profile information, recency, et cetera, and so on. It's the last 90 days of data that moves. But for historical reasons, especially if you want to do any type of analysis, we want to keep more data around. So we just expire it and move it into S3 automatically. And they're still visible in the UI, which is pretty cool. Who runs their own mail service inside of Amazon? Smart people. We calculated that the break-even point is at 1,000 messages per hour sustained. So that assumes 2 C1 mediums, because you need to be redundant, 3-year reserved, and then the cost per message, compared to the cost per message that Amazon charges you. And even if it were cheaper, I wouldn't even bother running my own postfix. You know, the EC2 IPs, they'll get blacklisted. You don't know what IP you're going to get. Some spammer might get the IP before you or after you. And then you have to deal with delivery problems. And SES, Simple Email Service, is a proper provider, so they'll deal with things like complaints and so on for you. All right, let's move on for this. Simple Queue Service. This is excellent for latency insensitive small volumes. $100 a month gives you 75 messages a second steady, and you can batch them with up to 10 messages per read and per write, so you can even get up to 750 messages per second if you know that's how your queue works. The problem, though, is delivery latency. It's between 20 and 200 milliseconds most of the times, but there are very significant outliers. Some of them are 30 seconds up to 60 seconds. So it's great for things like sending out a confirmation email or doing some post-processing on a job, but it's really horrible for things like real-time communication, maybe like an open WebSockets connection to your customers, or any type of high-volume queues, because the costs do add up. When SQS came out, we did a quick bit of math and was like, what if we put all of our logs straight into SQS and then process them from there instead of writing our own real-time pipeline? And there was a number that had many, many zeros in it, and we didn't think that was a great idea. It would have actually doubled our Amazon bill at that point. Right, the instance marketplace. If you're a seller, it's really straightforward. They sell well. The fee is about 10 to 12%, or basically a month worth of cost. And so the rule of thumb is, if you are going to use a machine for 5 months continuous, reserve it. Because every day after that 5th month is free. And then just sell it after. So the break-even rule for 3 years is, you're using it for a year continuous, year 2 and 3 are free. So given the fee, sell it if you're not going to be using it for more than 1 month either. So you've been using it for 5 months, or actually been using it for 2 months, doesn't matter. You're not going to be using it for months, sell it. You'll be better off. And if you're a buyer, it's really, really easy. It's a cost, it's a dollar for dollar comparison in cost, and it's often cheaper than what Amazon offers you because people have sunk costs that they try to recover, so you get a good deal out of it. And it's just a billing trick, so you get off really, really well. Dynamo. Dynamo and cost is an interesting one. It is great for small keys, and by small keys I mean item sizes less than 4K. You need uniformly distributed keys because you pay for the biggest key size. If you have a large outlier in there, it doesn't work. And if you're okay with embracing eventual consistency, as I suggest you should, you can get another 50% price cut on that. So 3-year reservation is a 75% price cut, eventual consistency another 50. That gives you, for $110 a month, 10K reads per second, reserved, eventually consistent. That's a lot. And we see between 2 and 10 millisecond latency on all of our calls. So this is ideal for highly available, fast, persistent key value store with a known key size. There's a slide later on about writes in DynamoDB, and the picture isn't this pretty. Who loves IOPS inside of AWS who goes like, these guys are so awesome, they really nailed IOPS for us? Yeah, said nobody ever anywhere. This is a graph of a log decompression recompression machine that we have. It sounds a little silly, but we get third-party data as well, and people will give it to in zip or gzip or LZO or whatever it might be, and we need everything in LZO. So we need to take it, recompress it, and upload it. So what you're seeing here is a machine that is using 4 disks for a total of about 1.7 terabytes, and it peaks at 5,500 IOPS combined. Now, you have a handful of options on machines. You can use an M1 X large, 4 2 ECU cores, costs you $124 a month reserved. You can use a C1 X large, 8 2.5 ECU cores for 25% more, $168 a month. And then you can compare this to SSD instances. So have 2 disks, gives you 2 terabyte, much stronger cores, but also at 500% of the price. You pay $650 a month. You do get up to 120,000 IOPS out of that, but most people don't write code that can utilize 120,000 IOPS. The alternative is EBS. Now, EBS volumes come into a 1 terabyte size max, so if I want 2 terabytes, I need 2 of them. I want 2K IOPS at least. That at least gives me 4,000 combined. Still not as good as the 5.5 I can get out of the ephemeral storage I'm using on this RAID 0 C1 X large. But I'm also paying the $650 a month that I was paying for the SSD instances. However, I still don't have an instance, and I'm going over the network. So it gets progressively worse as you go. Ephemeral storage, it's pretty awesome. Now, provision IOPS promises IOPS. Ephemeral storage does not. And that's because of the multi-tenancy, right? If you're on a T1 micro or an M1 small, there are many, many other clients on that same machine as you are. But larger machines have fewer guests, and the performance profiles have been very, very consistent in our experience. So if you go with a C1 X large or an M1 X large, you're going to see very, very consistent performance profiles. And for a free tip and how to avoid a little bit more, how to get a little bit more performance, if you have A-time and dir A-time on your FS, turn that off right now. There is 3 links at the bottom there. This is a very quick summary of all that stuff. There is more about EBS and SSD and ephemeral storage IOPS performance than you ever wanted to know. Go read that. All right, last chunk of the presentation, red flags and anti-patterns to watch out for. We talked about some good things and some good tools you can use. Here are the bad things you shouldn't be doing. Provisioned IOPS, EBS, like I just mentioned. The ephemeral storage works way better, and SSDs are way faster. The other downside with EBS is you're going over the network. Remember those first 5 outages we talked about? All of them took down the network. All of them would have taken down EBS. So because you insist on going off the box for your storage, you now have no storage. Odds are most of your code will be hanging indefinitely because it doesn't know how to deal with disks that never return. So stay local if you can. C1 and M1 X large or the SSD instances are the way to go. They are very, very uneconomical, even compared to SSD instances. So consider using a storage system that doesn't vertically scale on IOPS. Now that's easier said than done, and there are definitely some applications that insist and or recommend using EBS and provision IOPS. MongoDB's white paper on how to run Mongo inside of Amazon basically says get 4 of these provisioned IOPS EBSs, attach them to your master, and run like that. But if you're going to do that, at least use the instance types that have dedicated NICs to the SAN solution, or you're going to have a noisy neighbor problem. Netflix streaming movies off the box on different instances are saturating your NIC. So at least use any M whatever large or C1X large so you get that dedicated NIC. Amazon DynamoDB for high write rates and variable keys. This is the killer. If this is your pattern, basically don't use it. Writes are, first of all, disproportionately more expensive. Larger keys are more expensive. You double the key size, you double the price. So for a single write unit that you buy from them, you could have also bought 5 read units. So that's about that's a 5x cost right there. So if your app is write heavy and read poor, if you have a lot of writes per second, if your writes are very, very bursty and you don't know when exactly they happen, or you have very variable key sizes, so you have strong outliers, long tails, consider running something else like React or Cassandra on a C1X larger SSD instances. It'll make all the difference in the world. Also understand that changing the IOPS on Dynamo can be done, but only a few times a day. And it takes quite a bit of time to provision it. We see it sometimes taking as long as an hour to get the next bump. And they will accept at most a doubling step. So if you're at 1,000 IOPS now, you can ask for 2,000. So if you want a 10x on demand, it's going to take you a while. So bursty writes just will not work for you. And you end up reserving all that capacity that you don't usually use and paying through the nose for it. I would argue that high I/O, high disk, high RAM nodes tend to smell like vertical scaling. It's the easy way out. So smaller instances tend to be more resilient. They tend to be They tend to be cheaper than the few large ones, but there are a few exceptions. For SSD instances, the cost per IOPS is the lowest. If you can actually use all IOPS that the disk provides, you should be on SSD instances. You cannot get anything cheaper than that. For M1X large, for example, they have the highest network I/O for a low-cost machine. But these big machines have more than 10 times the network I/O for less than 10 times the price. So if you utilize the entire network, you should be on one of these big boxes. But in general, these instance sizes scale disproportionately to their smaller cousins. The cluster, the SSD, the storage, and memory, they're all very expensive unless fully utilized. So use them very deliberately. A tool that I wish that was better, CloudWatch. The good stuff. They're good for watching AWS resources like ELBs or SQS, things that you can't really run a host or run a client on the host to figure out what they're doing. They support custom metrics, and we use it for billing alerts, for example. So we have all of our billing information from AWS going into it and read it like that. Here are the cons. You can't get data out easily to other systems. The highest resolution is per minute, not per second, which I'm not sure what industry they're in, but mine says that every resolution is per second. You pay per metric, and it's 50 cents per metric. And the worst part there is that the incentives are not aligned. I'm penalized for using the server. As an operations person, I want to send you more metrics. I want to get more insights. But my business people tell me to send less. And now I end up curating. How much will it cost me if I don't know this information? Is not really something you want to be worrying about. And then if you do send lots of traffic there, their UI just breaks down at a high amount of metrics. You can't deal with it, and you can definitely not view it in a single dashboard. However, it is required for auto-scaling, so if you're using Amazon's autoscaler, you must use CloudWatch, and at least then you can use the custom metrics to scale on what you want to scale on. So a little alternative route here. Lower cost per metrics. This is a graph of the amount of metrics that we take in per second, which sits somewhere around 300, 350,000 a second. The cost per metric is a bottleneck in graphing, right? If Amazon charges me 50 cents per metric, then our bill would be $175,000 a month. That's not a good number, by the way, in context. It's a very bad number. If you look at Zirconis, for example, they have a way better pricing scheme than that. I think Platinum is at 30 cents a metric. Does it sound about right? Yeah, it's getting the nods. That would still make my bill about $100,000 a month, and I'm pretty sure that Theo would cut me a very good deal if I told him I wanted to send 300,000 metrics. He says my bill is zero. Close. I'm going to come find you right after this talk. Verbal contracts are binding. I have lots of witnesses. I think this is awesome. But we started out with Graphite, and the setup that we have cost me about $700 a month. It's 8 machines, 3 databases, and taking in 350,000 metrics a second costs me $0.002 per metric, sir. Am I using the Whisper DB for that? Yes, it's using Whisper. Are you using a different DB? Yeah.
Similar. We just keep running out of disk space after like 5 months. We keep having to add disks.
You keep running out of disk space. I didn't write that number down. We use the C1X largest, which come with 1.7 terabytes of data, and I know we have plenty of room to spare. The guys at Etsy suggested a storage scheme, which is 3 megs per metric, and that has been serving us pretty well. We did our own benchmarking as well and figured out, no, the guys nailed it. Of course, given whatever your constraints are and the granularity you need, you might not be able to deal with that same storage system. Etsy's, I think, rolls up to 10-second granularity at the end of the day or something like that, which is good enough for us, but it might not be good enough for you. So good point. Like, the more granularity you want, the bigger that file gets. Anyway, so the way we look at it now, it's 0.002 per metric, and we haven't even exhausted these boxes yet. We just need that many to make sure that they're resilient enough, so I could still do more, which makes the price go up. Here's what I can say, like, this is 150,000 times better than any other commercial system. It really isn't, because Graphite does graphing, it doesn't do alerting. But not every metric requires an alert. But hosted solutions tend to not differentiate, right? If I send you a metric hosted solution, you will let me alert on it. But I can't easily send you lots of metrics that I'll never alert on. And that's what drives the price up. Graphite exports data as JSON, so you can build your own alerting on top of that. And we definitely do that for some latency monitoring. So I bashed a little bit on hosted alternatives. But I actually think there's 2 really good ones. And I'm not just saying this because I'm at an OmniTI conference. This is actually from previous slides, too. If you want to host your metrics and alerting, I'd say go with Circonus for what we've used them for and what my friends use them for. They are absolutely fantastic. I love their visualization. I love their custom graphs. I love their heat maps. I love the math, and I love the alerts. But, you know, in my case, it breaks the bank, although it won't anymore, apparently, which is awesome. There's a company that just started called Stackdriver. They're in private or public beta, I forget. We have a key there, and it's pretty awesome. And they've optimized it around AWS. And what is really neat is that they understand the alerts that aren't machine specific, so for things like ELBs and so on. And they give me a unified dashboard for the AWS alerts across all regions and across all accounts. And if you've ever dealt with AWS retiring an instance, they send you an email to the account owner's email address, and then hopefully somehow you didn't forget about that and did something about it. So these guys, they fix that for us. We get PagerDuty alerts for like unbalanced ELBs and AWS things that break. And we get a PagerDuty dash as well for things like a retirement is coming, a maintenance is coming. You might want to do something about it. At least just lets us visually see it, hack it, and make a thing. And their thing is a fixed cost per resource with 25 custom metrics for $8 an instance. So especially if you don't have a big infrastructure yet, or you're just starting out, or you want to monitor things like ELBs, definitely way to go. Both Circonus and Stackdriver have a statsd output module as well, so you can send metrics their way at the same time you're sending it to Graphite, so they go nicely together. Mix and match, forward just the stats that you want to alert on. My recommendation would be send user-facing metrics like app response times and error rates to things you want to alert on. Send them to Circonus, it's a really, really good idea. And the rest, like, we don't have dashboards with 350,000 metrics on them, but we do use them for diagnostics and everything else. All right, last 2 slides. CloudFormation. Pros, keeps your AWS stack in sync for you. It's easy to set up when you're pre-automation. It avoids a bunch of API calls for things like security groups. It's free. Cons, managing the templates sucks. It's very finicky JSON. It's very easy to break. There are no comments. There are no partials. It's one big monolithic file that you need to manage. Also, everything in the template needs to be managed by CloudFormation. Everything. So if you manually edit or alter it through the API or UI, you can get CloudFormation in a broken state. So if you do things like changing a gateway, which is what we do, the way out of the data center is a handful of ways. If one of them fails, we want to switch over an IP address or a route or whatnot. You can't do that because you put CloudFormation in a bad state, even if you put it back afterwards. Moving EBS volumes around, same problem. And we've gotten it easily to states where we could only fix it by deleting the entire stack and relaunching it, which I don't think is a great failure case. Best use case, define your network stack, your security groups, your ELBs, and CloudFormation, the stuff that are hard to manage anyway and that are fairly consistent, and where such a thing like a master list actually makes sense, like a master list of your security groups. And then finally, RDS for analytics or reports. Like I said before, if you're using RDS for analytics and reports, Redshift is a great analytics database. So what you're doing is you're paying OLTP prices for analytics usage. The read slaves are going to be very, very costly. Part of their capacity is going to be taken up by write replication. Your master's disk will become very large due to the older data that you have in there for reporting. Most of that data for reports is stale anyway. It's for rollups and so on. You really don't need up-to-the-minute data for it. And no matter what happens, your queries will be constrained by a single node, no matter how large. And you'll end up vertically scaling those. And then whenever your developers want to take a database dump, they're not going to have to take these few terabytes of data and load them up on their laptops, which won't work. So now you're trying to figure out how to sift through the data and give them a representative set. So compare, Redshift is about $83 a month. An RDS M1 large with a 3-year reservation is about $320 a month. So it kind of makes sense there. And even if Redshift isn't the right answer, EMR or Hadoop may be. So consider that seriously. With 14 seconds to go, for the 10 minutes Q&A that we have reserved, any questions? Sir? If you have any experience with Amazon SNS that just launched, no, we have some developers playing with it, but nothing near the numbers that I was talking about here. If you have any experiences, I would love to hear about them, though. That'd be great. You too, okay. Any other questions? Sir?
I just want to clarify, are video streams off the CDN for Netflix instead of AWS?
Sorry, the video stream from Netflix is on a CDN. Yes.
You can't be a noisy neighbor.
Yes, but you can be a noisy neighbor. So I get it right for the next time, you encode the videos onto, or on Amazon instances, and that result of that encoding is being streamed off once. Is that right?
Yeah, we should test it.
Excellent. I will not call you out like that next time. Thank you for that. Any other questions? Go ahead, sir.
Several times you mentioned that a certain type of instance is twice as fast as another type of instance.
Right.
Or your comparative measures of IOPS or network ops. Or
Right.
Are those your measurements of how those, or are those published numbers? And if they're your measurements, how do you find a lot of variance between specific instances of specific instance types?
So the question is, for when I said this instance type is better than that instance type, are those my measurements, are those published numbers, and how do we find out? A bit of both. There are some published numbers. The problem with Amazon, I would even argue it's a feature, is that they are expanding so quickly that they're adding racks and racks and racks every hour. Hardware gets newer, and their overbooking rates tend to change as well, and and their virtualization is getting better too. So they use a very custom version of Zen, and we've gone through a big maintenance wave lately. I'm sure you've all gotten the emails that they're slowly starting to upgrade them, but we can definitely tell the difference whether you're on older hardware with an older virtualization system and versus a newer one. Like US West 2 performs better. They try very hard to standardize this stuff, but I have response graphs over machines that run in all these data centers, and they're in the microseconds, and I can tell that everything that runs in US East is hovering around 400 to 500 microseconds, and everything in US West 2 is 250 to 350. And it's things like, L2 caches. I get better ones, great. So the numbers definitely vary. They vary mostly from older hardware to newer hardware. That's why I said use US West 2 rather than US West 1, which is older hardware. And a lot of it comes definitely from benchmarking and from the places where we found that the variance is too unpredictable. We found ways to work around it. For example, when we log our incoming requests, we don't log them directly to ephemeral storage. We log them to RAMFS for about a minute and then rotate them out. That is just to absorb the spike in case a noisy neighbor makes the needle move like crazy. So that's how we get around that stuff. Thank you.
Do you ever spin up a new machine, test to see if it's a lucky one or a bad, and if you don't like the way it feels, just try it?
Do we spin up new machines, see if we got lucky, and then rinse, lather, repeat? We've mostly found that we've found ways to work around that variability, but I know plenty of people who do it. Reddit is famous for this. They will spin up 100 machines and keep 1 or 2 of them. There was a question somewhere in the back as well. Yes, sir. This cost comparison, M3s versus C1s. The M3s are EBS root only. And that is a thing that we don't want to do. So no, because I'm more concerned about what happens when their EBS solution doesn't work, which has been a common occurrence. So we run ephemeral where we can. Sir?
Follow-on question. Since the trend seems to be that they will get rid of ephemeral storage at some point entirely, what will your doc sound like then?
What will it sound like when they get rid of ephemeral storage? I hope my story will be something like, back in the day, when the thing was real, these were the problems, but bless their hearts, they've sorted it out and figured out how to make EBS work. Because we want to use it. It is a smarter way to go, but there are things that can still break. And I think one of the cool things about Amazon is that they have hundreds, if not thousands, of engineers trying to solve these problems, so I don't have to. And hopefully by the time that they've gotten to the confidence that EBS is good enough, it is indeed as good as we want it to be. So here's to hoping. Any other questions? Sir?
Do you have a EC2 VPC split, or do you just put everything in multiple VPCs?
Do we have a split, or do we put it in multiple VPCs? We've started transitioning to VPC as a default. We started way back in the day before VPC was a thing, and it turns out that the API calls are sufficiently different. One of the things I don't like about Amazon, that we'd have to actually change a bunch of our stuff to work properly. So we'd prefer to use VPC as a default, which is available everywhere but US East 1. So we're in the prototype stage there, but since a lot of our stuff runs in US East 1, we've not been able to make the switch. So I don't have much experience there. Sir?
The long-term vision of your company, do you ever foresee running hybrid, some of your database systems on hardware you own and running scale in the cloud? Do you think you'll remain in the cloud all along?
Do we think there's ever going to be a hybrid model? We do this exercise every couple of months. We look at what the costs are going to be. Running a data center requires some expertise. There's a trust that you have to have either in remote hands or you're going to have people on site. Amazon is doing a great job moving the goalpost for us every time, because the numbers I had last time I looked, it's like, oh, we're a year away before that happening. And then they go, we reduced all the costs. We made this more awesome. But yeah, I can definitely imagine a time of that happening. And I think Amazon's Direct Connect is going to play a huge role in that, which is their way to hook up a data center to their cloud. There's some feature stuff that we really love, like S3 and Elastic MapReduce and Dynamo, that we definitely want to keep using. And then there's a whole bunch of stuff that we think we can probably run better ourselves. So yes, I definitely see that as an option. Any other questions? Awesome. I'll be right down here if you change your mind. Thank you for coming today.